Hi everyone. So next we are going to start chapter number 7 from Unit 5 Transducers. Okay. So here in this first lecture we are going to discuss about the transducers and different type of transducers classification. So first of all we'll see what is a transducer. You know, transducer is a device. It converts energy is one form to energy in another form. Once again, I will repeat. Transducer is a device which converts the energy in one form to another form. That is actually transducer. But electrical transducer, what is doing that? It converts any form of the signal is converted into electrical signal. Okay. Why I am giving the in general definition. In case of transducer, it converts any form of energy into one form to another form. But in case of electrical transducer in examination, the bit is there. It converts any form of signal into electrical signal. Okay, that is our option is correct. Now we'll see. The most of the transducers convert electrical energy. See here, electrical energy into mechanical displacement or convert the some non-electrical physical quantities such as a temperature, light, force, and sound to electrical signal. Okay, some of the transducers are doing. So see here, you are given the physical quantities here. It is given to the input of a transducer. So what is doing that, if you are given some excitation to this particular transducer, what will happen? The output is converted into electrical. Okay, this actually the transducer is. Okay, now in case of electronic instrumentation, the function of transducer is being as input device to detect. That means it can be detect or sense the presence of magnitude and changes in the physical quantity being measured. That means that in industries all the maximum quantities of physical quantities are there. For physical quantity measurement, that can be converted into electrical quantity and measured in the digital display like voltage and current relations like that. So it is possible with the help of these transducers. Okay, now we are going to classify the different type of transducers. Transducers are classified into two types. The first one is a passive transducer and active transducer. So passive transducer is nothing but they required external supply and the output to measure some variation in the physical parameters such as a pressure, resistance, and capacitance. Got my point? If you want to use the passive transducer, some external power is required to convert to sense to measure the pressure, resistance, and capacitance to convert into electrical signal. So some external excitation is required. Those transducers is nothing but a passive transducer. Coming to the active transducer or self-generating transducer. The name itself, they required, actually they not required an external power source. They not required external power source. Those transducers are called as a self-generating transducers. Okay, so just replace here not required. Okay, then only it is a self-generating transducer. So we'll see different type of transducers other than electrical transducers. See, first mechanical. So in case of mechanical transducer means, in case of mechanical applications, strain gauge is a type of measuring force or torque and pressure. Strain gauge is a transducer which measures the force, torque, and pressure. It senses the particular quantities and convert into electrical quantities. In case of temperature, thermistor and thermocouples. Thermistor and thermocouple categories of thermal. In case of optical, photoconductive, photoemissive, and photovoltaic cells are the examples. In case of aquatic, that is a microphone. Acoustical, that is a microphone. In case of magnetic, LVDT, linear variable differential transducer, and parameter. Okay, next one, chemical. In case of chemical, pH and conductivity cells are related to the related transducers. Next, nuclear, Geiger and Muller tube ionization chamber. Those are the example for nuclear. Biological electrocardiograph, that is the ECG, that is related to the transducer, that is a biomedical. Okay, so you just know we saw the different type of transducers. Now again we are going to classify based on the electrical principles. So now our focus is to related to the electrical. So based on the electrical principle, how they are classified. See here, based on the variable resistance, and based on the variable inductance, and based on the variable capacitance, as well as based on the voltage divider, and also voltage generating type. These are the classification based on the electrical signal, electrical principle. The first one, variable resistance type. Strain gauge and pressure gauges, both are one of the types. Strain gauge is one of the type of variable resistance, and thermistor and resistors and thermometers, those are the related to the variable resistor, photoconductive cell, chemical conductimeter, contact thickness gauge, etc. is related to the principle of variable resistance. It is a working based on that. Next, we are going to working based on the variable inductance, that is the LVDT, linear variable differential transducer, reluctance pickup, and eddy current gauge. These are the related to the inductive type. And then capacitive type, variable capacitive type, capacitor, microphone, dielectric gauge, and pressure gauge. Voltage divider case, potentiometer position sensor, and pressure and actuated voltage divider. And then at the last, voltage generating type, piezoelectric transducer. You know, piezoelectric transducer is a example for self-generating. Okay, active transducer is a voltage generating type. Thermocouple, photovoltaic cell, rotational motion tachometer, all are active because they are self-generating the voltages. So these are about the classification. Okay. Next we are moving to the one by one. We'll see resistive transducer, capacitive transducer, and inductive transducers one by one. So very simple. So we are moving to the resistive position transducer. So this is a resistive position transducer. In this case, we have a one is a conducting strip. This is a conducting strip. Other one is some mobile shaft is present in between, and then here A and B terminals are connected to this particular solenoid. Right now, in this particular case, what will happen? See. It is used to what happened? It uses to sense the position of an object at distance is moved. So the main principle of this particular transducer is to measure the distance or position of object. The physical variable being measured made to cause the resistance change in the sensing element. Whenever it is a moving, the equivalent variable resistance will be changed. That means that convert into electrical element. So now here AB are the sliding contacts, and RDB is a resistance depending upon the position of object, and V0 is the output. Here this is the V0 is the output. So total entire this particular circuit is converted into electrical circuit. This is a voltage input, as well as this is a resistance R1 and R2. The C output is a variable terminal. V0 is available here. Now how to calculate this output voltage? V0 is equal to, apply the voltage division rule. V0 is equal to, you want voltage across the R2, that is R2 by R1 plus R2. That means that voltage is proportional to the resistance. Okay. Now we'll see the advantages. We got my point. How to vary this resistance? We can position this particular shaft is varying. This particular movement in the C variable terminal, then voltage will be changes. Resistance will be changed, and automatically voltage will be changes. This is about the resistance transducer. It is electrical efficiency is high. It provides the sufficient output to permit the control operations without any further amplification. So the device may be excited by the either external DC or AC source. That's why it is a passive transducer. That means it is required external AC or AC source to excite it, AC or DC source, any one source. The limitations here, moving part is there, that is a mechanical friction because of moving parts in the resistance variation element, as well as noisy, because whenever it is movement, noise is also one of the drawback for these particular transducers. Okay, next we are moving to the one example based on this particular transducer. What is saying that displacement of a transducer with a shaft stroke is 75 mm is applied to the circuit. Okay, the total resistance of a potentiometer is 6K, voltage is a 4.5 volt. When the wiper 25 mm and from the end B, what is the value of V0? So this is the circuit we have. In this particular case, I need to find, I know the total volt resistance is a 6K, R1 plus R2. So, R2 value is equal to 6000, that is a potentiometer resistance into, what is the variation? 75 and 25. Okay, 25 divided by 75, that is a R2 is a 2000. Once you got R2, V0 is equal to V into R2 by R1 plus R2, you will get 1.5 volt is a output voltage. So next we are moving to the resistive pressure transducer. In the resistive pressure transducer, very simple. Whenever pressure is applied to this particular inlet, what will happen? This particular inlet, it is a movement is downwards. Whenever movement is downwards, the length of the element decreases. What will happen? R is equal to rho L by A. Whenever length decreases, what about the resistance decreases? Whenever resistance decreases, it sends the resistance value. It sends the equivalent resistance value to measure in terms of current or voltage signal. So the resistance equivalent. So the pressure converted into resistance, the change in resistance measured in terms of electrical signal will measure that is the equivalent of pressure calibration. We are doing the calibration first of all. So that's what here, it is based on the arrangement with change in the pressure is the result change in the resistance by sensing element. Once when applied to pressure it changes, the spring supported below the B extends or contact by moving the resistance slide and up and down. So now consequently change in the resistance sensing resistive element becomes a proportional to the change in pressure. The change in resistance can be made part of the bridge in the circuit. You can see where whatever the change in the resistance, that change in resistance connected in the particular balanced bridge. Whenever this particular balanced bridge it is connected in the balanced bridge, part of the balanced bridge, and then AC and DC signal pressure is determined. So in terms of AC or DC signal, pressure is determined. Okay, whenever it is a balanced, whenever before it is a balanced, we are connected to this particular case. In that particular case, what amount of change in the resistance that will be flow in the deflection meter. That means that you can sense the pressure directly proportional to that. Next one, inductive transducer. So inductive transducer is also same thing. So here the inlet pressure is applied here. Whenever inlet pressure is applied, the change in self-inductance of a coil is also changes. See here, in case of change in pressure produces a change in self-inductance. So inductance of a sensing element. This is a sensing element. When a pressure being measured increases below the B expands and hence mobile magnetic core is pushed inside, thereby increasing in self-inductance. Okay, so how it is increasing self-inductance? L is equal to mu naught mu r n square A by L. N square A by L. Whenever you are more pressurized to this particular circuit, what will happen? Length will be decreases. Whenever length will be decreases, what will happen? Inductance will be increases. That's what you are working of this inductive pressure transducer. So when applied pressure is decreases, the below the contacts, thus the magnetic core is pulled out from the coil and result is coil is inductance is decreases. Whenever pressure is removed, what will happen? The sensing element length will be increases, the inductance will be decreases. Likewise, the change in inductance is taking place, that is converted in terms of pressure in terms of inductance. Inductance will be connected any bridge or any other circuit will measure the particular inductance values in terms of voltage or current, DC or AC signal. Okay, that is about capacitance measurement. So the advantages here, no moving parts used there, avoiding the wear and tear. So no extra friction load is imposed on the measuring system. That's what here advantage is. Next, coming to the capacitive transducer. In the capacitive transducer, it detects the capacitance, variation in the capacitance. So, a change in the pressure detected by the variation in the capacitance in a parallel plate capacitor. Let us see. This is a static plate. This is a movable plate. This particular M-shaped ring, this is a movable plate. This particular M. So now capacitance C is equal to epsilon naught epsilon R A by D. Whenever I change the distance here, whenever I change the distance, dielectric media, what will happen? The capacitance we can increase or decrease based on the movable plate moving forward or backward. So this means that capacitance is inversely proportional to distance. Whenever distance increases, capacitance decreases. Whenever distance decreases, capacitor increases, vice versa. So the capacitance consists of a static plate, that is a N, and movable plate, that is M, separated by the dielectric media, that is a air. Okay, dielectric media, that is a air, is present. Now the question here, M bends and we are applying pressure towards M. Yeah, the distance decreases, hence capacitance increases. Similarly, whereas the pressure decreases, the diagram in the pulled out the towards and D is increases, and consequently capacitance decreases. So change in capacitance can be part of the capacitance bridge to calculate the value of electrical signal equivalent to the pressure to measure. The pressure we are changing. So that's what your capacitive measurements. So we'll see the advantages. The advantages of capacitive transducers is inexpensive and easy to construct. So particularly effective for the high frequency variations. So you can where you need to calculate the high frequencies, high frequency signals, we can use this particular transducer. Capable of measuring both static and dynamic phenomena. Okay, both we can measure. So disadvantages is sensitivity of the temperature variation, possibility of the erratic or destroyed signals due to the long leads. So those are the advantages. This is about the part 1 video. In the part 2 video, we are going to further remaining topics. Thank you.